In this lesson, we're going to be solving absolute value equations. The first step is to isolate the absolute value. Since we have a 2 in front of the absolute value that's being multiplied, I need to get rid of it by dividing both sides by 2. So that means I have the absolute value of 3x minus 2 equals 7. At this point, we need to understand what our absolute value means. Remember that absolute value is the distance of number is from 0. Maybe you might think of it as when we're taking the absolute value of, say, 2, the absolute value of 2 stays 2 because really the distance from 0 to 2 is 2 units. The same thing happens though if I have the absolute value of negative 2. The absolute value of negative 2 is also 2 because the distance that negative 2 is from 0 is still 2 units. But with that idea then is that if I'm talking about in general form the absolute value of x equals 2, that means that the x that's inside the absolute value can have two potential solutions of positive 2 or negative 2, as we've just seen from the example that I brought here. What that means in terms of us solving is that in order to solve for x, we need to actually set up two equations to account for the fact that the inside of the absolute value can either be positive or negative. So what we're saying is that in order to get a positive 7, the equation equal to a positive 7, either we can have the inside 3x minus 2 equal to a positive 7, or we can have the inside 3x minus 2 equal to a negative 7. At this point then, we just want to solve both equations for x. So on the left-hand side, 3x minus 2 equals 7. Moving the 2 over, we would have 3x equals 9. When we divide out the 3, we would have x equals 3. On the right-hand side, we would have 3x minus 2 equal to a negative 7. So we would have 3x minus 2. Moving the 2 over, 3x would then equal a negative 5. Dividing both sides by 3, we're left with x equals negative 5/3. So these would be your solutions to the absolute value equation. We get two answers and you can go back in and check to see that even though the inside might be negative, when we take the absolute value, we're talking about distance, so we'll end up getting a positive. So our solution set here would be 3 and negative 5/3. So same idea with this problem. We have the absolute value of x plus 1 plus 6 equals 2. So first we want to move that 6 over, so I would have the absolute value of x plus 1 equals a negative 4. At this point, we need to stop and think back again what the absolute value means. Remember, the absolute value means the distance a number is from 0. Well, that number is always positive. Right now, we have the absolute value of x plus 1, or the absolute value of some quantity, equals a negative number, equals a negative 4. Well, this can never happen. An absolute value will never yield a negative number. So as soon as we get to this point, there's no other work to do. Since our distance can't be negative, we have an answer of no solution. There is no solution. So we'd either say no solution or the empty set. So no, not much work to do as long as you can identify the fact that if I move the 6 over, we would get that negative 4. So whenever we have the absolute value equal to a negative number, there is no solution. If you did walk through this by hand, say you made two equations, you had x plus 1 equals negative 4 and then x plus 1 equals positive 4, walked through that, when you went back to check, those two solutions would not work in the original equation. So just keep that in mind, is that if you are going to always walk through it and solve, make sure to go back and check to verify that neither solution works, which is why you'd have no solution. So one more problem with solving our absolute value equations here. If I have the absolute value of 3x minus 2 plus 4 equals 4, I'm going to move the 4 over, so that way we have the absolute value of 3x minus 2 equals 0. Well, at this point, we also need to stop and think, is that if the absolute value is the distance a number is from 0, well, the distance that 0 is from 0 is just 0. The inside absolute value is just going to be 0. There's only one solution, because even if I were to set up two equations, I would have 3x minus 2 equals 0, and then 3x minus 2 equals negative 0. Well, negative 0 is just 0. So you can save yourself some time and just understand is that when the absolute value equals 0, we're only going to get one solution. So we would just have 3x minus 2 equals 0. So 3x equals positive 2, solving for x, so x is equal to 2/3. So the only times when we have an absolute value equation that we're going to get one solution is if the absolute value equation equals 0. So just a quick summary of the three examples that we just had. If we assume that b is a positive real number and a is any real number, if we have the absolute value of x plus a equals b, so equals some number other than 0 and some number that is positive, we would have two equations which would give us two solutions. We would have x plus a equals b, and then x plus a equals negative b. If we have the absolute value of x plus a equals 0, this means that we would set up one equation which would yield one solution, just x plus a equals 0. And if we have the absolute value of x plus a equals negative b, then that means we would have no solution because there's no way that an absolute value can equal a negative number.